Hello everyone. In this video of Linux, we are going to talk about shortcuts, hard links, symbolic links or symlinks, and also the idea of inode. Okay, so let's get this started. So if you go to any place on your system, let's say home, downloads, or anything, these things that you see, these items, are basically the file names. Okay, each file name also each file, in addition to a name, it also has a bunch of metadata, right? Like the readability, writability, whether you can execute it or not, who owns it, what was the last time that somebody tried to access this file, modify its data, change its metadata or anything, right? Those are all stored in something called inode, okay, spelled this way. And this is the information that any file has. And this is separate from the name of the file. So let me tell you here. So look, if I go to this home, you see I have this file called myfile1.txt, right? And that's the name of it. But if I say ls, right, dash l, I for inode, and then myfile1.txt. So you see that here there is a number in the beginning. What is this number? This number is what we call the inode number. Each file, the metadata of that has a number, and this is called the inode number of the file. Now, you can see it shows you the reading and writing capabilities. It shows you basically the name of the owner, right, and some extra information. If you want to see more information, like when was the last time somebody tried to access it, when was the last time somebody tried to modify the data of it, the metadata of it or something, there is this command called stat. And you just ask it to give you all of those metadata information. So you say, give me stat of this, and now you have better results. First of all, you see the inode number. You see this is the name of it, this is the size of it, it's a regular file, this is the basically kind of access to it. Now the last time that somebody tried to access it was just like a few minutes ago. This is the last time somebody tried to modify the data of it, actual data, like the lines that are written in it. And this is the last time somebody tried to modify the metadata of it. And this is the time that this file was created. Okay, so these are the info of the inode. And this is the inode number. Good. So this is the first thing that I want to emphasize for you. Now, moving on, I want to talk about shortcuts or links to a file. There are two types of shortcuts or links to a file in Linux. One category is called the hard link. The other category is called the symbolic link or symlink. What are these? What do they do? Pros and cons, how to create them, and some more information. So what is a hard link? A hard link is basically referring to the same metadata, to the same inode, but with a different name and even possibly in a different location. What does that mean? So let me show you here. I use the command ln. ln is standing for link, means I want to link this file, this myfile1.txt. I want to create a name for it, a different name in a different folder. That name also refers to the same metadata, to the same inode, right? You see right now my file 1 is here in my home directory. Now I want to make one here in what? In the downloads. So what do I say? I say ln, and then what? I say, I want you to create a link to this my file 1.txt, right? Link it to under downloads, link it to a new name called my file 1 hard link .txt, right? So create a shortcut of that, a hard link shortcut of that in the downloads folder. Let's go and look at downloads now. There we go. You see this one is created here. And if I open it up, you see this one has the exact same data that my file does, right? So why would you do that? You had it already here. Why would you make another one here? Well, first let me show you something, that these two, although two different names and locations, they are referring to the same metadata, so they have the same basically inode number. To do that, here we are going to compare basically their inode number. How do I do that? So here we are going to use the ls command. I can do that to compare, right? So I say, hey, ls and then -li as I showed you, but here I'm gonna provide both of the names. So my file 1.txt, which is in home, and what under downloads, that my file 1 hardlink.txt. Show the inode of these and compare. And look here, you can see that they have the exact same inode number, and that means they are basically referring to the same kind of metadata. Okay, now you might say, well, couldn't you just copy this file, my file 1, to the downloads? What's the difference between this one and a copy? I'll tell you what. First of all, when you copy a file, you are creating a separate inode and separate space and storage on the disk. And the most important part is this. If I change the content of my original file, which is this, that copied file that I copied to downloads, the content of that will not be affected. Okay, because these are two complete separate files. But look here, I go to my home and I change the content of this guy, right? I add some extra line, for instance, or I can delete something. So here I add some extra line and save it, right? Now let's go and look at the one in downloads, right? This hard link of it. You see? Immediately shows the same result. Why? Because this one actually does not have its own data. It's the same inode as the other one, so basically this is just a mirror of that. And not only it will reflect that change immediately, the good thing is this one does not need extra storage. This is just a shortcut. Now you might wonder what happens if by any chance I go ahead and delete this, right? If I delete the original file, right? So let me delete it temporarily and go here. Is this guy still available? Sure. Can I still open it and see the data of it? Yes. So you see, this is really good when you have basically backups, when you have updates in the system, when you have several software that need to refer to the same thing, the same content, but in different locations, and you want to make sure if one of these files is deleted, the other ones still exist and can be used, right? This is the power of what? This is the power of the hard link. So you deleted the original, this one's still there, completely functional. Okay, so let's see if I can bring it back. There we go. So clearly this is really great. Now What's not so good about this, or what are the limitations? What are the limitations of a hard link? Where hard links are good if you just want to create a shortcut of a file, not a directory. If you want to create shortcut of a directory, you should not use a hard link, because each directory has parents and children. And if you try to create a mirror of that elsewhere, now your whole file system is going to be kind of messed up and confused. So you never want to create a hard link out of a directory, only file. The other thing is, if where you copy this, right here, you see I copied it from this location to another. If these two locations are different file systems, different kind of structures of files, right, like XF and NTFS and something, different type of file systems. If you try to copy one from one file system to another one, this is not gonna be allowed for a hard link. A hard link cannot cross different file systems, because each one of them has a different way to number and name the inodes, and because their numbering of inode system is different, it cannot cross file systems. So it has limitations, it has powers. Now there is a second one that is called a Symlink or symbolic link. What is this one? First, let me create it and show you how to create one. Then we're going to see the pros and cons of that. How do you create a Symlink, a symbolic link? So remember here, this is how I created one, right? Now, to create a symbolic one, all I need to say is -s, means make it a symbolic, right? Make a symbolic, and I changed this name to Symlink instead of hard link. So go ahead and under downloads, create a symbolic link from this my file 1, right? Now if I go there to my downloads, look, here I made a symbolic version. This is the hard link, this is the symbolic one. But if you look here, there is something wrong with the Symlink. First of all, it's locked. Second of all, it is missing the link, the proper link to the original file. Okay? So, to show you this, let me demo that with the cat command. I want to show you the content of these files. So I use a cat command. Let's see, I should have it. So I use the cat command and I say, hey, go ahead and show me the content of my file 1.txt. Well, it prints it here for you. Now if I say go ahead and do it for what? Do it for the downloads, and then my file 1 hard link.txt. Could you show the content of that? There we go, no problem. Now if I say do it for the soft link, or Symlink, I'm sorry. Do it for the Symlink, huh? Look what happens. So I say show the content of the Symlink. It says, hey, no such file or directory. So clearly you see that it cannot find the link back properly to the original file, and for that reason it cannot show you the content of it. So what went wrong? I created it, but seems like this file is not really doing its job. So this is what I want to do. And this is my recommendation. If you want to create a Symlink, use absolute addresses with $sign and quotation mark, and avoid going with a relative address, although this is not relative. But since I'm in this folder and I'm gonna send it to another folder, and then when I want to run it again, I'm running it from a different folder, this is not what a Symlink is gonna accept. So do it this way if you want to do it. And it's very similar, right? We bring that, this one. So here is the same idea, except for the my file 1 and the file in download, for both of them, target and the Symlink, I'm using their absolute address for both. Here, look, here for this one I did not use absolute address. For this one I used the relative address because I am in the home directory. For this one I did absolute, for this one I did relative. That is what gets it confused. But if I use absolute for both of them, right, and create it, and let me make this small m, right, okay, look, it created the file. Now if I go and look at it, look here, you see all of those logs and the cross and everything is gone. Now if I double click on this, I can see it now. Even the Symlink opens for me. And if I say go ahead and show me the content of this guy, right? So go ahead and use the cat command and show me the content of this. Look here. So when you want to create Symlink again, make sure you use absolute address for both target and the Symlink. This is one. Now you might say, what is the difference between the Symlink and the hard link? Apparently I can show the content of both of them, right? So what is the difference? I'll show you the difference. Remember we used this ls-li to show what? To show you the inodes for the original file and the hard link. And they referred to, they were the same file basically, right? With different names, different locations, but the same metadata. Now what about the Symlink? Does it have the same basically inode number? Well, let's find out. So what do I do here? I say this time for me, go ahead and do that, right? And let me do the same thing for this one as well. So $home dash forward slash, right? Oh, I did wrong. Let me fix this, right? So compare the inode numbers of these files, but here I just want to make this what? The Symlink. Okay, look. What do you see here? They have different inodes numbers. They have different inode numbers. And what you see for the Symlink is what? The Symlink is referring to what? To your original file. So that means this guy is just a link. It's linked to this guy. Even you see that the read, write, and execution permissions are different. Another thing you see here is for the original file, there is a 3 in front of the permission. What does this 3 stand for? That means not only the original file is referring to itself, there are 2 other links that are referring to this. Remember, one of them is the hard link, one of them is what? The Symlink. To show you better, let me do something. I want to also bring in the hard link one. Okay, let's do that. That might be more interesting if I do the hard link as well. There we go. So now show all 3 of them in the same place. There we go. Look. You see that the hard link and the original files are the same. Their rights, permissions are the same, everything, but the Symlink is different. So basically you can say that a Symlink has its own metadata. Now what about the actual data? So you say, well, you just showed me, you double clicked on it and it shows me this, right? Okay, so let's ask this question. If I get rid of this original file, this one, what happens to the Symlink? Could it still show me the content? So let's go ahead and delete this. and go to the downloads. Look what happened to the Symlink. You see, it got broken again. If I want to see it, I can't. I cannot double click on it. I cannot use the cat command to show me anything. So now this file is broken, or what we call dangling, right? Because the original content is gone. So what is a Symlink really? It's just an address. It's just a path name and metadata, a different inode number referring to the actual data of the original one, but it does not have its own data. It has metadata, but not these lines. These lines of text, it does not have any of them. It was just a path. Okay, so if this one has this kind of limitation, and of course because it has different metadata, it means it has a little bit of storage in the system, why would you need a Symlink in the first place? Well, because Symlink has some properties that the hard link doesn't. Like what? Well, one of them is a Symlink can be used to create a shortcut for a directory, as well as what? The file. Remember, for hard link we never use it for directories, but Symlink doesn't care. You can use it for different directories. Also, if your target directory and your Symlink directory are in different file systems, it doesn't care. It can cross different file systems. So a Symlink is extremely flexible, okay, and powerful, because all it cares about is the path, right? But of course, if you lose the original file, it is going to go broken. So you see, hard link and Symlink, each one of them has something to offer. The last thing I want to show you is this command called readlink. You can apply it to a Symlink, and it shows you where it is referring to, right? It shows you the address of the original file. So if I apply this to this Symlink, right? Say, hey, tell me where this Symlink is referring to. Sorry, I did the hard link one. Symlink, it only works on Symlink, right? Show me where this Symlink is referring to. It says, hey, guess what? It was on the home directory, this file called myfile1.txt. Okay, so these are some commands that I showed you: hard link, Symlink, inode, stat, and readlink. And these are, as I said, very good for creating backups when different software need to refer to the same thing, updates of software, and a bunch of other applications. So hopefully it was useful to you, and I'll see you in the next video. Thank you.